chance? Or
Yeah, we'll get it going just to make sure.
make sure it works.
Let's see. All right. Thank you. All right. We're going to get started here. And so the first thing I'd like to see if we can have somebody volunteer to take notes. Shouldn't be too difficult. Just want to catch major points in the action items. Any volunteers for note taker? Going once. Thank you. All right. So I'm Joe Salloway. We also have, I think, Ben, you're on the Meetecho. All right. Ben is on the Meetecho. All right. So you are probably familiar with NoteWell at this time, but NoteWell kind of describes the different processes in the IETF, in particular about IPR and related issues, and then also about anti-harassment, and also trying to treat each other with respect in our working group meetings, keep conversations civil, and let's work on technical discussions to get the work completed. All right, everybody should join the meeting using the on-site tool, so you can join the queue. People who are online should mute and have their video off until they are ready to talk. All right, we have a few things on the agenda. We'll have a brief update from the chairs on current document status, and then some discussions on anonymous rate limiting, and then Watson talking about new directions in rate limiting, and then talk about credit tokens. Any additions or modifications to the agenda? All right.
Yeah, I think I'll need less time than Sam, so I'd like to give 5 minutes of my time to Sam's presentation, because I think there'll be more discussion on his.
So you said you give more time to Sam?
Yeah, I think I can
Okay.
do 10 minutes and he can get 15. I think it'll work a little better.
Okay. We'll try to adjust that. I think we'll have plenty of time, but we'll see. Ben, did you want to?
Agenda Bash, I believe that ARC will be presented by Kathy Yun, not Chris Wood.
True.
That is correct. Thank you.
Okay. So working group items, we have batch tokens is complete, I believe. That's just in working group chair, go ahead. We're working on getting, I don't think, Ben, do you remember if there was a revision necessary for that one?
I think we've gone through the revisions on that.
Okay, then it's just probably waiting for Shepard write-up and then pushing the button to send it to the ISG. The private tokens and public metadata, we went through working group last call. There were some requests for updates on the list, so we're waiting for a revised internet draft for that one. And we recently adopted expirations extension as a working group item. And we'll have a talking about the anonymous rate limit credential today, and I believe that we'll be doing an adoption call soon on that one. Anything to add, Ben?
Nope. Just we're very tight on time for this session, so we're going to keep it moving.
Yep. All right. So we will go to the first presentation.
Awesome.
I'll put up the slides and I think I can
Yeah.
pass the,
Okay. Cool. Hi, everyone. I am Kathy. I will present on anonymous rate-limited credentials today. We call that ARC or ARC for short. My co-author, Chris, presented on this last IETF meeting, so hopefully this is familiar. I want to go through, sort of review some of the details and then ask two really key salient questions to the working group that I think are interesting and important to address. Awesome. So you all are familiar with this. A recap of the PRIVACYPASS issuance protocol is that we have the origin sort of give a token challenge, and you use that token challenge to, with a token request and token response, make a token that is then given back to the origin. I think the instantiation that we are the most familiar with is using blind RSA, where the final token presented is a standard RSA signature and incorporates the original nonce. This should not be new to anyone, but just want to sort of recap. This is RFC 9474, and I think it's super great, deployed at scale, really useful, but does have two main drawbacks that I see. The first drawback is that there is no per client rate limiting, which means that if I am a malicious client, it doesn't prevent me from necessarily overloading the system. It only rate limits the entire system. So that's the first one. The second drawback is that each token requires its own issuance. So if you want to, as a client, redeem N tokens, you have to get issued N tokens. There's two ramifications. One is that there is a privacy concern. I think depending on the application, this can be quite sensitive to learn the client's usage rate. So if I fetch a new token every time I change locations or access a sensitive site or a sensitive service, it could actually be pretty privacy concerning to learn my usage rate, and the tester can tie that usage rate to me. The second, more operational concern is that there's just a large issuance overhead. There is a high issuer load, and especially when you have a lot of clients accessing the service a lot or with bursty access, this can just be operationally difficult to handle. And of course, we can deal with this by issuing batches of tokens, and we have a few ways to deal with this. But at the end of the day, even with batch tokens, in order to redeem N tokens at the end, I have to request N tokens. The batching is just a little bit of a help. So you're probably thinking, for number one, don't we have something already that addresses that? And yes, we have rate-limited PRIVACYPASS, which addresses the per-client rate limiting piece by allowing the mediator to do per-client rate limiting. I think this is great, and this builds on the RSA blind signature scheme and is adopted by this working group. And I think this is really great news because it means that there is both appetite from this working group. Oh, lost audio. Okay, hopefully I'll just keep going. It means that there's appetite from the working group to adopt proposals that address this per client rate limiting. And my pitch is that we can do this, but better with ARC. So that's my, I'm going to be making the argument. Yeah, the argument is that ARC is basically a better approach to the tokens than potentially the previous adopted spec. One, just like the previous one, it supports per client rate limiting. And this, unlike the previous spec where the mediator or the tester is the one doing the tracking, the rate limiting, saying, hey, Kathy gets like 100 tokens per day. Instead, the per client rate limiting is built into the cryptography, which means that each client's credential, and you get one credential, at least in normal use cases, each client's credential inherently rate limits that client. And the second one, which is, I think, a big significant improvement, is that you can create many tokens from one issuance. This is because one issuance allows you to create one credential, and you can derive many tokens from that credential up to the rate limit per epoch. So I think this is super powerful, and once again is good for both privacy, so you don't leak usage patterns, and also for just operational overhead. So casting the ARC workflow into the diagram that we're familiar with, what this looks like is that the client gets a token challenge from the origin, makes an attestation with the tester, and then through a credential request and credential response, they create a credential that they hold locally, and they use that credential to create tokens, as many tokens as the rate limit allows per time period, or per presentation context is what we call it, and reduce that to the origin. You might notice that here the issuer and the origin are sort of the same party. We're treating them as one party, and that's because one of the properties of ARC is that it is keyed verification. And so I will discuss that a little bit more. So just to explicitly lay out the comparisons between RSA-based rate limit tokens and ARC, they both offer per client rate limiting, but ARC has what I think is like a pretty big improvement in terms of being allowed to do one-to-many issuance to token ratio. You can do one issuance and make many tokens from it, which has better privacy and the lower issuance overhead. But there is a potential drawback, which is that the way we've designed it, it is only private key verifiable. And this is because we wanted to use sort of standard NIST curves, didn't want to use pairings. However, it is relatively, well, trivial depending on who you ask, but it's solvable with pairings. And this is sort of a drop in, it moved to a pairing group to verify kind of transitions. So it could be solved. And my question to the working group is making a public key verifiable version of ARC that is also has the same properties of client-based rate limiting, is this of interest? And the second question, if this is of interest, should this be in scope for the ARC spec, or would this be a separate spec? It feels to me like this should be a separate spec because the deployment contexts are pretty different, but question to the working group. I can see that being argued either way. So that's my first interesting question. I have a second question, which requires me to go a little bit more in depth into the details of how the ARC tokens are constructed. So bear with me here. I'll try to keep it relatively high level. The ARC token in the current spec contains, among other things, a nonce. This is a value, an integer between 0 and the rate limit that's currently set in the clear. So you as a user, given a credential and a presentation context, and you can think of presentation context as either an endpoint or a date or a combination of endpoint and date, but that's sort of the context in which that rate limit is being enforced. You can only use that nonce once. And that's because the nonce is used for the tag, and the tag is the thing that's actually used to enforce the rate limit. Specifically, the tag is derived deterministically from the nonce, the credential secret, and the presentation context. What this means is if you have a different a different nonce for a given credential secret and presentation context, then your tag will be different and you will not hit your rate limit. But if you reuse your nonce, then you'll have the same tag. And that's what allows us to detect double spends, sort of just like blind RSA tokens. If you double spend, then you should be rate limited. So hopefully that makes sense. The salient takeaways are that you have a nonce, it's currently set in the clear, and we have a tag. And that is the thing that repeats if you reuse the nonce. So this is a really nice, simple construction. However, there are privacy concerns, or potentially privacy concerns. This is a question for the group again. What if the origin sees two tokens that have the same nonce? And once again, you could see this because the nonce is set in the clear, but they have different tags. So as a recap, for one credential, if you use one nonce, it will always give you the same tag for presentation context. So what this reveals is that these two tokens must have come from different credentials or different presentation contexts, but we're assuming, assume they're the same presentation context, then they've come from different credentials. And in practice with many users and pretty high rate limits, this may not have a significant privacy impact. It just sort of reduces the anonymity set of what credentials this tag or this presentation might have come from. But I do want to call out that this does violate the PrivacyPass privacy requirements, which are that you cannot distinguish between N tokens that come from the same client and N tokens that come from N different clients, like fundamentally here. You know that there are two different cases. So I want to ask the working group, like, does this feel okay? It seems sort of like at face value that it doesn't, and then you're probably wondering, like, what can we do? What are the other options? So the other options are that we can hide the nonce. The hiding of the nonce is possible, but we have a few options here that also have other trade-offs. The simplest way to hide the nonce is to basically say, hey, we're going to allow a power of 2 rate limit, and this allows us to use fairly simple to specify and simple to implement proofs to prove that the nonce is in range. This has relatively low size and low cost overhead. However, the power of 2 restriction on the rate limit is a little bit weird. Right now for PrivacyPass, none of the tokens say, hey, you can only have a power of 2 rate limit. So my question is, like, is this acceptable for end applications? Or is this pushing up a weird detail that we'd rather not push up to the end adopters? The other option is that we can have an arbitrary rate limit. And the pros are that this is way more flexible. The end users don't have to see this weird property. The cons are that this is requires more experimental, complex cryptography. It's harder to specify, harder to implement, large size and cost overhead, convergence as to like one solution that would be best here that is like sort of ready for standardization. So these are options, I guess, to recap, because I threw a lot of information at you. We have 3 options for the nonces that I see. One is that you can have a public nonce with an arbitrary rate limit. And then obviously, if you send it over, the verifier, the origin, can trivially check that it's in the rate limit by looking at it. That's our current design. It feels insufficient for privacy, but maybe it's good enough for large-scale deployment. I don't know. I want to discuss this with the working group because you guys are the experts here of like what is an acceptable deployment, like what's good for deployment. 2, we can hide the nonce using a power of 2 rate limit. That is pretty simple. We know how to standardize and specify that, I think, at least I would argue that. But then you have this power of 2 rate limit limitation, and 3, we can hide the nonce with an arbitrary rate limit. And if we want to do that, I actually don't really know what's a good way to standardize, specify that. It's significantly more complex in terms of cryptography. So this is a question for the group. So yeah, let's recap. The next steps are, I'd like to discuss what the nonce options are and what the preferences are. I'd like to get a general idea of like the interest in extensions, like are folks interested in a publicly verifiable extension? And is that something that would live in this spec, in this token type, or separately? My inclination is that that should be separate, but I do want to ask the group. And then lastly, we think that ARC is like a pretty great and sort of improvement over existing rate limited, client-based rate limited PrivacyPass types. And we'd like to sort of see, is there interest in moving towards adoption of ARC as a PrivacyPass token type? Cool, that is what I have. And I see that there's a lot of questions queued up. So I will stop presenting and we can go to questions.
Yeah. Let's go, Samuel.
Hello. For the public verifiability, I think it's great. We don't currently have a publicly verifiable CMZ, but we could have one, and then the spec could be very similar. Like we could have basically all the same text and just have like 2 paragraphs that change it. So I wouldn't mind having it in the same spec just to minimize work. And then for the nonces on the list, last time we discussed this, actually somebody chimed in with a way to extend the power of 2 proof to arbitrary rate limits in a way that is not the square sum approach and is exactly the same. Basically, you just like subtract a number here. And so I think we do know how to specify that. Or no, you're shaking your head. Do you want to?
I think it's a approach. I'm not attached to that one approach, but yeah, it does make the like novelty a little bit less daunting. It's still a little bit novel, but yeah, we can go ahead.
Yeah. But then on the other hand, I think I would still support adoption as like a work item, even if we don't do that. And I think working on it here and adding the hiding of the nonce seems good. That's all.
Great.
Thank you.
Raphael?
Yeah, thank you for the presentation. It was really clear, and thank you also for shedding some lights on some more aspects that I didn't quite catch at the last IETF. So my question is regarding the decrease in privacy. So is it fair to say that this is actually pseudonymous from the point of view of the origin? Meaning the origin sees a pseudonymous client that comes back again and again with a different token, but always the same pseudonymous identity?
This is a great point. The way that we are trying to construct ARC, we're not trying to construct pseudonyms, at least as far as the origin is concerned. Every tag it sees should be unique. As long as no one's going over the rate limit, abusing the system, all it sees are entirely unlinkable tags, where those tags are not linkable to each other or to a credential. However, if you allow a user, and this is, I want to be clear, this is different than what I've just explained. If you allow a user to reuse a nonce, or you have your rate limit set to 1 per presentation context, then you basically get pseudonyms almost for free. And so this is very similar to the BBS pseudonym construction. But that's not how we've designed it. That's not what we're pitching.
Right. So it's not inherently the case if you don't want that property. Okay. Thanks for clarifying.
Okay, Tommy?
All right, Tommy Polly Apple. Thank you for bringing this. I have a couple of different points. So one, you were referring a bit to the original rate limited draft. Just wanted to comment there, that was not only about per client rate limiting, it was actually very focused on per origin per client rate limiting, which has its own particular use case. I think that's a nice use case. It made things way too complex, as we all know. And it is possible, and I think we've talked about before, we could just have the per client rate limiting that's using the existing types that the attester does, but it's still pretty expensive to run. So the nice thing about token types like ARC is that it makes that per client rate limit very cheap based on a credential. So the client can just run it without having to talk back to the attester all the time. But then I want to point out to people it has this property with the presentation contexts that it becomes very trivial to regain per origin per client rate limits or any other number of other properties like per time frame, per server properties. So I think it satisfies the intent of the original rate limiting draft and goes far beyond it in terms of utility and simplicity. So I would like us to see adopt ARC and replace the other draft. And I'm a co-author on that one, so I'm happy to throw it under the bus and get rid of it. Then to some of the points you're making, for the publicly verifiable part, I don't have a strong opinion there. If there's a simple way to add it, I think that's really cool. And with regards to you're saying maybe it's a different spec. Ideally, we can do it in one spec. We did the original PrivacyPass types in one spec. But even if we did want 2 specs because they were sufficiently different, I would maybe suggest that there should still be some common overall document describing this ARC style, because hopefully they would both fit into that. And I think it's really valuable. And I think one of the main values of what you've done with this draft is kind of that architecture of how we take these new crypto types and turn them into something that is sensible and usable in the PrivacyPass architecture. And I think that should be unified and crystallized somewhere at least. And then last thing about the power of two rate limit, it seems like it'd be a really weird constraint. So let's please not have that. And I could see a world where if most use cases are okay with this little chance that you could recognize that 2 tokens are potentially from different clients, that we just say, yeah, you have to do power of 2 if you don't want that property, and a client that's really picky about it would reject using ARC for anything other than power of 2, but we could also find a clean way to solve this problem. Thank you.
Chris?
Yeah, so I'll just give my opinion on all the questions. Yeah, excellent presentation. I definitely support adoption of this work. I think it's we're already pretty far along. As far as private versus public verifiability, I think it's up to you guys as the authors, like in my opinion. But I think given that the only solution we have right now is like pairing based, and the maturity of that crypto is, I mean, so like private versus public verifiability for PrivacyPass is like VOPRF versus blind RSA, and those are already far along. I think ARC seems to be further along than BBS, just from my current understanding. So I would say it's fine to ignore it in the draft. Thank you for bringing up the privacy concern about the nonce. I think hidden nonce should be a requirement. I would be fine with the power of 2 limitation for now. And if people decide that we need more flexibility, we can complicate the protocol at a later time to add that flexibility. So that would be my take on that. And then finally, I had a question. I guess how much like leeway do you as a draft author feel comfortable with for making changes to ARC specifically, say to accommodate like adding new features? So like say I wanted to do like a range proof on an attribute at presentation time. I know you're going to do like a Sigma protocol presentation at CR4G, so we'll kind of learn about how that works. But like, are you amenable to kind of protocol level changes in PrivacyPass to accommodate these things?
Yeah, I think that last question is something I don't have a great answer to. My general feeling is I think if you're trying to deviate from the ARC protocol, like you add an extra attribute and then you're proving something, I feel like that's no longer ARC. It's no longer compatible with the test vectors. It's no longer compatible with the protocol, but you can still do that. You could just do that as almost like an ARC extension, ARC++, or like whatever you want to call it. And
So
it
that's
should be fairly straightforward to do that with Sigma protocols, but yeah.
That's what I'm asking about, is how much flexibility is there to extend ARC?
Yeah, I don't know of any, and tell me if there are actually examples of this or appetite for this, but like my understanding is that PrivacyPass token types are like fairly locked down. It's like this does this one thing, this is exactly like this shape and compatible with these test vectors and nothing else. And I feel like the thing that you're asking for would be really nice, but I don't really know how to make that one token type. Like that seems like you have a token type, but then you have modifications such that token now looks different. So I don't really know what that would look like in a way that would still be useful as a PrivacyPass token type. But I'm down to keep discussing that.
Yeah, I mean, I think it's an open problem. Also, this is hypothetical from my point of view right now. But for use cases we've been looking at for ARC specifically, we've been wondering about like how do we extend this to add some functionality, and that's kind of open and amorphous right now. But I just wanted to like gauge from you, like, is there room to add flexibility if needed? But we can table that for now.
All right, Chris.
Awesome, thank you.
Yeah, thanks, Kathy. To the questions, I definitely think, like Chris, that we should have the nonce be hidden. It would be a super awkward regression compared to like the other PrivacyPass tokens that exist. Have this like weird property that is like not at all listed in the registry. So when you're like choosing a token type, you might not take this into account. And of course, we could add like a lot of language in the document that like guides applications in the right way towards taking this into consideration. But I doubt it would be read. Doubt it would be useful. It'd be easier to just hide the nonce. To Chris's question about like whether or not we'd be amenable to changing things, once the draft is adopted, it is no longer our opinion as to what goes in the draft. It becomes the working group's like opinion and objective to do what the working group deems is necessary. So if the working group says we need to extend it to support this, additional proof over some new attribute, whatever, that's what we'll do. So I mean, that becomes a question of what we do after adoption. But we should absolutely do an adoption call, please, so we can get this process started. Thank you.
Thibault?
Hi, Thibault Meunier, Cloudflare. So first of all, I don't know, really good work. I have like tons of comment. I will try to be fast. But one on the option like for rate limit, you had like 3 options, either like public rate limit, powers of 2, or like fancier crypto. I do agree with Tommy that powers of 2 is a bit weird, but there are definitely like some like nice privacy consideration with that. So I do think that's something that we would have to consider for the trade-off between like option 1 and 2. For the again, echoing like what Tommy said about like the previous rate limiting draft and the property of having rate limits per origin. I think this is a very nice property. I'm not sure how we will reconcile and like make this guarantee directly into the draft, but something that I think like, could be worked on rather than having only client rate limit. Once again, that's like a property of credential, which seems very appealing to like reduce the number of tokens and weight that would be done on the issuer. So yeah, definitely like very much looking to have that forward. And finally, on public verifiability, that's I think a very nice property, but I don't think it's required at the moment. If we can like at least move and like experiment like with this anonymous credential, seems to be the right way to go. That's it. Thank you. I would support adoption.
Thank you. Stefan?
Yes, hi, thank you. Just apologize first that I know very little about this working group, very little about work. I haven't read the draft. I just stumbled in here because I'm heavily involved in European wallet projects and the IETF, and I just read the charter and stuff and felt that, wow, there are so many similarities here about what you're doing and what's done in the EIDAS and the European wallet ecosystem. So I'm just curious, has there been discussions of synergetics between what's going on in Europe, what's going on here? Is there a reason for us to look into these specifications? Or, I mean, is there anything you can say about that?
I can't speak for all of PrivacyPass. I think specifically for ARC, especially because it's key verification and you basically have to update the issuer. That seems like it's a no-go for EIDAS, but that's just from my understanding of the constraints of EIDAS. If that's not the case, happy to chat about that more offline, but I know we're out of time. Thanks so much, everyone. Really appreciate it.
All right, Watson.
Joe, very quickly, process question for the chairs. David Skenazy here. I know the queue is closed, but before we move on, can we hear from the chairs what your plan is? So you're planning to start an adoption call on this?
Yeah, I think so, because it's clear that there's a lot of interest in this work. So we'll start this adoption call soon after.
Great. Looking forward to see you. Thank you.
Yep. All right, Watson, you should have control.
I do. I just tested it. Good afternoon, everybody there in Spain. We're here to talk about some new things that have happened with rate limiting that open up some possibilities. So where we were last meeting was we have these BBS schemes, and they're sort of well improved implementation, but there's some limitations. And there's limitation to the expressiveness of what you can put in terms of constraints. And there's also this problem that the rate limiting, if you have a quantum computer, you can figure out the key that was embedded in the credential and see whether it was the same one used multiple times. And if you did circuits, then you can do, you're saying like AES. And we know that even a quantum computer can't figure out the key for AES, so can't link up different shows. Both are, you take a PRF of a key and your context, but the PRF can be more secure when you do this whole arbitrary circuit thing, which at the time was sort of becomes expensive. Well, so several things have happened since then. There's a recent deprint, and I'm sorry I did not put down the author's name or the title, but I put down the URL that shows an information theoretic rate limiting approach. There's a bunch of other things in the ePrint that aren't deployable. The title is Everlasting Anonymous Rate Limited Tokens. It's by Rushan Tatira Abiram, Nico Doting, Anna Lysenko, and Stefan Tesoro. Then Google released its age verification tech based on circuits, where they have an e-print describing the whole thing, and they've implemented and put it somewhere. I can't remember. And then the circuit security of some of these big advanced proving techniques got a lot scarier in post-quantum because everybody was throwing around the ROM, and the ROM just doesn't really work for these protocols. It turns out, they're just saying, like, make your hash function more complex in the circuit. So let's talk a little bit about the information theoretic rate limiting. And the basic idea is we can think of we have two giant tables. And the input to the PRF lets us index these tables through some polynomial of some degree. And the game the attacker's playing is they're essentially getting back these entries, and you can draw a little graph, and it's a bipartite graph, and you're drawing an edge between an entry of T1 and an entry of T2 if they were ever queried at the same, if they were added together to produce an output the attacker knows. And the attacker wins if you get a graph that has a loop in it that's bigger than the degree of that little polynomial on the end. And the paper has some limits in the results. There's some implicit constants here and some slack that gets you a not great answer at the end if you look at realistic sizes. I've thought about what happens when you put in a hypergraph. It's a little better. There's places where they're not using all the information that this graph has to have a cycle in it. But that's sort of the idea. And how do you put a table into a credential and reveal and do a verified thing where you say, okay, I've got an entry in this table. Well, circuits is easy. And if you're in the BBS world, one of the things you can do is just say, oh yeah, instead of issuing one credential, I give you 1,000, and they're all the same, except they all say, oh, well, in the entry for table 0, table entry 0 is this, and entry 1 is that. So there's tricks to avoid to make some of the stuff simpler, or they use polynomials in the paper. Anyway, this is ideal, but that's the idea. And the big thing about this is information theoretic secure, meaning no adversary, even if they can solve any computational problem, can ever link these showings. So what's sort of the bottom line? Well, there's a large solution space. There's different technologies, so there's circuits versus BBS. If you don't mind the setup costs and the huge amount of work it is to make one of these circuit proving things, but they're getting better all the time, then you got to do a lot more. There's questions about how you issue credentials. One of the big things about circuits is you don't need to change that. Multi-issuer, that we haven't really talked about it here, but that's very possible. Rate limiting, now we have a way that's post-quantum secure. Bottom line is really sort of how do we navigate this trade-off space? And I'd like to use the rest of the time for questions.
Any questions? All right. Up, Chris.
Hey, Watson. Thanks for the presentation. One of the challenges I think the PRIVACYPASS suffered from is this this desire to chase after shiny things. There's a bunch of fancy crypto out there that can do interesting things, and we've tried to like fit it into the architecture that we define for the very basic, like VOPRF and blind RSA variants. ARC is interesting in that, while it's like somewhat different crypto, more fancy than blind RSA by comparison, it's very concrete. Like we've sort of like whittled down the huge solution space into something that's like very simple, I guess, or at least maybe that's my personal opinion. Can be implemented and specified well. And so we put forth like a very specific solution to a very specific problem. I think many of these directions that you propose could probably be pursued if they were solving like a problem that people cared about. And the challenge seems to be like trying to take like a real problem and sort of building a solution around that, if that makes sense.
Yeah, it does.
Which is to say, I'm not like trying to discourage like people thinking about this stuff or work on it. It's definitely relevant. Like we wouldn't have things like ARC and BBS if people didn't do this sort of like exploration of the design space. But I think the salient thing that this group needs to think about is like, what are the actual problems that we want to solve with PrivacyPass, and then try to use whatever crypto is necessary to solve that problem, rather than start the other way around and look at like all the shiny crypto and then try to extract a problem from it.
Yeah. So what I'll say in response to that is, in the last presentation, there could have, and there wasn't, a column saying whether or not someone with a quantum computer gets to link all your credentials. And that column would have been no for RSA and yes for ARC and any, regardless of public viability. This solves that. So if what you care about is keep the same simple privacy properties from the RSA thing, the idea like this, which I don't think, it's not that complex. It's basically throw a random thing out every time instead. But there's a queue. So I think it does solve a problem. I think the other things might not, but I think this definitely solves.
Okay, that's good to know. Like I would just like maybe shift the presentation around and be like, this solves that problem that ARC introduced, that regression that ARC introduces. I'm speaking in reference to ARC because we just talked about that, but like whatever. All I'm suggesting is like, let's focus on the problem, not the crypto that potentially provides a solution first. But anyways, thank you.
Okay, we're running out of time, so please make your comments brief.
Yes, Thibaut Meunier-Klaafler, want to poke on what Chris Wood just said. I don't think these are problems we should not chase. I do think there are priorities in terms of what we should chase and what seems to be important right now. To me, ARC definitely seems like tackling the problem, which I do feel the group should work on right now. Like the multi-issuer stuff and etc. is very interesting and definitely brings a lot of like nice property that I do think the group would care down the line. But into more priority, I would prioritize ARC as well.
Okay, Dennis. Oh, okay. All right. Thanks, Watson.
Thank you.
All right. Just get... Okay.
All right, great to see you all, and thanks for the previous presentations. Today I'm going to present an idea that I have called anonymous credit tokens. Next slide. This is work with my collaborator, Professor Jonathan Katz. Slide. So what we've done in PrivacyPass so far is that we've shown that we can separate an action from an actor, and that's enabled privacy in a whole bunch of contexts that we haven't been able to have it before. But as its success has led to so many people wanting to implement more privacy features, we've run into some limitations. Slide. One limitation is that these tokens are individual and or atomic, like there's one token that you get. And so if the tasks that you're decoupling the action from the actor for are different sizes, then it's not necessarily a neat fit always. For instance, different bandwidths to a proxy. Next slide. Further, there's really no way to react to abuse and have a feedback loop such that you can protect your service or protect users or protect the world. So like, for instance, somebody might ask an AI system to produce a very harmful bioweapon, and you might want to discontinue all of their access from that point on. But you can't do this if you offer anonymous access with a large number of tokens. So you see here, as time goes on, you see some fraud, and then some stuff proceeds, and then there's some very bad harm that maybe you could have prevented if you had some feedback loop, but we can't do that in a clean way right now. Next slide. So to solve this problem, I have thought about this idea called an anonymous state machine. So this is an idea where an issuer will grant you some well-formed initial state that it essentially signs or gives you a message authentication code of, and it contains a secret nullifier K, which will prevent double spending. And whenever you see a green arrow in the talk, that's going to have an interaction with an issuer sort of embedded in it. I think this is like a neater way to view these things. And so when you want to transition this state, the issuer will authenticate and observe some transition T that the client requests, and it will note the nullifier K. If K has been seen before, or this authentication of the transition fails, then there will be no further issuance. Otherwise, we'll issue you a new token with a new nullifier K with the updated state. The issuer does not see the state. They only see the transition. And so there's configurable privacy in here. And like someone said earlier, we don't want to introduce privacy foot guns. You have to be careful here to pick your transition set correctly such that you are having small enough or large enough anonymity sets. But to make this specific, let's talk about a specific example of anonymous credit tokens. Slide. So here, the initial state is a value, which is the number of credits you've been issued. And let's say the client wants to spend S credits. So the issuer will verify that S is less than or equal to the balance, C. They'll observe S and K the nullifier. If you've seen the nullifier before, then that means that you have seen this token and it's an invalid spend or a double spend. Or if the authentication doesn't work and S is greater than C, then we won't issue again. Otherwise, we'll issue this refund of C minus S. And Kathy pointed out that you can actually deduct less than S credits, but that's sort of a detail. Next slide. You can also do things like count abuse. So you can have an abuse counter that starts at 0, and then the issuer can verify that the abuse is less than some limit that you want to enforce, and observe the nullifier again. And same thing, if the abuse count is above the limit, or K has been seen before, then we don't issue a refund, or don't issue the updated state. Otherwise, we issue, based on an abuse signal, A+1, or A if the abuse was not present. Next slide. So with these things, because they're based on the same technology that ARC is based on, these zero knowledge proofs based on Sigma protocols, it's very easy to take the AND of two of these state machines. And so we can combine the credit tokens and the abuse counters. Next slide. And so here I have a visual of anonymous credit tokens with abuse counters. And so you see that we spend 60 credits on a large task. And then the next time we spend 10 credits on a smaller task, and we see abuse, and we do an abuse count, abuse increment. And now that the abuse is greater than or equal to the limit, we're not able to proceed with the state further. Next slide. And now we kind of have a problem, right? Which is long-term abuse tracking. So how do we propagate that abuse signal back to the issuer? Because in a lot of these cases, abuse could be really serious. Next slide. One solution you could propose is that you could return the abuse counters after your use. And so again, you have to be careful about anonymity sets and how you're doing this, but this is auditable by the users of the system. They can communicate and count up how much privacy has been violated by this abuse count. But this allows you to have a long-term sort of feedback loop between your private system and the user accounts or the user identity that you're issuing these things to. And you can notice that actually users can choose not to return their abuse counters, But of course, this itself can be a strong negative signal towards their trust, like the trust that you might have in them. Next slide. So something that's a little subtle here that may not have been noticed is that this actually changes slightly the model of what issuance gives you. So for single-use tokens like blind signatures, the resources allocated is equal to the number of tokens issued, which is also equal to the number of concurrent sessions that you can have with the system. For anonymous credit tokens, the concurrent sessions is equal to the number of credit tokens you issue, whereas the resources allocated are the number of credits issued inside of the tokens. And so if you go to the next slide, you can see that this allows us to have kind of complicated feedback loops where you can potentially have a certain number of sessions, and then you see a bunch of abuse for that user, and you deduct the number of anonymous sessions that they can have. And this can be very helpful because now you can say, here's a system that I want you to have access to, like let's say some sort of proxy, and you could say, I want you to have 500 sessions with this many gigabytes each of bandwidth. And so compared to the existing systems that we have, which allow you to have a very large number of blind signatures to do this type of thing, here we're able to have a small number of anonymous credit tokens and tamp down on the total number of concurrent usage that an individual user can be having. And you can see that we can say reduce the number of sessions that a user is going to have after they commit some fraud or abuse. I think this might be my last slide. Is that right? Okay, yeah, so I've written a specification for the cryptographic primitive, and there's an implementation. There's no abuse counters in that one. It's just the credit tokens. And the main question for the group is basically, is this work going to belong in PrivacyPass? For me, I think it's natural. Because I have so much extra time, I'll actually say some things that aren't in the slides. So we were talking about linkability on Q-Day, and the previous solution, ARC, does permit linkability on Q-Day, which is a shame. There are some solutions that we could have, like Watson's suggestions, but these tokens do not permit that linkability because every single time you go get a new token, you get a new nullifier, and that nullifier is not going to be invertible in any way. And so we get that nice benefit. I think that there's another thing I should mention, which is Thibault implemented this using blind signatures, and you can do this, but it just has like subtly worse privacy properties. It's not so bad, and it's easier to implement, but when you add things like abuse counters, the privacy properties get like much worse. And so this type of solution, I think is a little bit preferable to using blind signatures for this. Next slide. All right, so the main question is, does this work belong in PrivacyPass? Like, do we think that this is a natural evolution of these types of tokens? And, is this something that should belong here in this group? Thank you.
All right, Scott.
Great, thanks for presenting this, Sam. I am really excited about this work. And, I am basically a deployer of one of the systems that's trying to use way too many blind signatures to represent, quota for a particular system. And, I do think having this variability for what the actual usage was on the back end, not always appropriate. It depends. But, it's not hard to imagine systems. You mentioned AI serving systems. I think that's a great example because we have systems where on the back end, we're going to decide, hey, maybe we'll respond in 1 token. That costs you X. Maybe we'll respond in 1,000 tokens. That costs you 1,000X. And it's up to the backend system to decide. You also have similar systems where, we've used these for proxies before and you're charging, or you would like to charge per byte, ideally. So I think that property is really useful, and I'm very excited about the potential for abuse control as well. So, and to answer your question directly, I do believe it belongs in PrivacyPass because, I am deploying a system today that's using PrivacyPass to do this. And I think this is a really nice extension that lets us fix a lot of the problems that we're currently handling with, enormous amounts of tokens today. Instead, we have a much more elegant way to do it. So I'm very excited about this. Thanks.
All right, Tommy Polly Apple, thank you for sharing this. So I think this is definitely very interesting. I think overall, like these properties about being able to give feedback or have spending or handling costs like that, it's something that I've seen naturally come up in many discussions around PrivacyPass use cases. Not all of them. Like I think there are still places for basic tokens and rate limited tokens, but I feel like this flavor of there's like an extra bit of interaction going on here, right? And I think that is something that's very natural in certain fraud prevention cases or trying to spend quota in different ways. So I think there's definitely a something there. And I think that something there is related to this group. I guess looking at the spec you have, like it's mainly the crypto bits, which is cool. And I'm not a cryptographer, so like I want other people to analyze that. But I think for this group particularly, what would be great to see and work on together is something that's going to explain how the interactions between the different roles work. How do you put the system together? That's what we've done in the other documents here. And maybe that's, concretely how it's going to work over HTTP, what kind of values go where and what shuffles around. And I think that would be a great thing for this group to help analyze and tackle based on the crypto work. So let's do that as the next step for looking at with this group.
Yeah, I totally agree with this. I should say that I've written it out a couple times, and it does fit within the framework, though you can write it in uglier or prettier ways. So we should definitely look at a document like that next time.
All right, Chris.
So I think this totally. Do you want to mute the mic in the room? Oh, I'm still echoey, but I'm going to keep going. I think this totally can fit into Privacy Pass. I'm a little, just in general, like I think sometimes the Privacy Pass working group has made decisions like there is this privacy thing that is like becomes application specific. Like if you mess this up in your application, then the crypto is not going to give the intuitive security privacy property that you want. So I guess like being really clear about like the limitations there. I mean, I haven't looked at the draft. I'll look at the draft like once it's. It sounds like you want to flesh it out a little bit more, but yeah, I think totally something we could work on. But yeah, that would be my main concern.
David Skenazy, Google. So from the perspective of IP protection, which is something we have at Google, where now we're running traffic through proxies, you can't use IP addresses for a lot of this stuff. We're interested in this work. And I want to add +1 to what folks have said. Some of it might land in CFRG, some of it might land here. We'll need some cleanup, but that's totally solvable. So looking forward to hearing more on this.
Hey, Thibaut, Cloudflare. Yep, I do really like this work. I will comment, I think, echo a bit what Tommy said. Definitely a document which has like a lot of crypto part, which is like very interesting. And once again, not a cryptographer, similar to Tommy. I think the document that has been presented to IETF ago about like reverse privacy pass, trying to describe more of an architecture that would fit nicely. And definitely, I mean, we had discussion outside of the list, and I would definitely be very happy to contribute and see this forward. Yeah, that's it. Thank you.
Well, I just want to say that this is definitely an interesting problem that we have been thinking about, and actually have a draft that we plan to take to CFRG that deals with some of the like fraud prevention, fraud tracking properties. I do think this does maybe a better job of integrating that into the protocol for certain settings. And so I express adoption, but I don't really have opinions as to what venue that this best lives in, whether this is Privacy Pass or CFRG, evidently because we're thinking of taking Atom to CFRG. This is also a question for us, but generally do you think that this is worth solving and a good problem space to work on? Thanks.
Hey, Eric Troughton, new to IETF. Very supportive of the proposal. I think it's a great idea, and really love the private feedback mechanisms, because I think it definitely beats a lot of the alternatives that we've considered, which tends to be kind of like some sampled set of data that gets kind of exposed and used for modeling. I am kind of, and maybe I should have asked this during the ARC presentation, but I'm kind of imagining that like one of the key problems that we have with the existing Privacy Pass is it's designed to not be linkable, and therefore it's very hard to detect abuse. And so I'm kind of curious of like, it sort of seems like there's an assumption here of like going to per client would be easier to make sure that there's no token harvesting attacks. I'm kind of curious if that's something that folks are comfortable talking about in terms of the use case behind it. And I know when fighting abuse and talking in public, it can be difficult to have some of those conversations, but would love to kind of know more about what folks are comfortable sharing. Thank you.
Dennis Jackson, Mozilla. I think this is really interesting. I definitely want to see this progress and like be better understood and be figured out. Whether this belongs in like PrivacyPass, literally, I don't know, but just because a bit like with what Chris said to Watson, there's a lot of like to figure out on the exact problem statement that we're solving. And it might be that like a recharter or a different working group, but I want this to continue somewhere, whatever that right place is. I think is really great.
Yeah, can I briefly respond to some of those points? Sure. So on the draft that I have already, it's the CFRG draft, and then the PrivacyPass draft will reference that. And then on the linkability, I think this is actually not very different than like public metadata or something. So to me, it feels like it doesn't even need a recharter if public metadata is permitted in the group. And I should note that I agree strongly that we should have like very explicit guidance on how to calculate the anonymity sets based on your deployment in the draft for PrivacyPass.
All right, thank you very much. And that is the end of our current agenda, and we are out of time. So good job, everybody, for keeping on task. So I think we have one adoption call that I'll be working through, and then a number of other documents that are kind of at the other end of the process. So thanks, and we'll see you next time.